I started. Just Gautam, give a minute as they come into the room.
Okay, so we'll wait for 2 minutes, I think, yeah. 1832, so 1834 will start.
For those on the call, we are just going to start in a minute. Gautam, I think we can get started now.
Yes. So good evening, everybody. I am Professor Gautam Datta, retired faculty from IIM Ahmedabad. And with me in the panel is Rajesh Tyagi, who is GE Global Research. He is a retired person, and he is also the president of Informs Practice Section, and he is the chair of the 2023-24 Franz Edelman Award. So this series we are doing, possibly this is 7th or 8th seminar which we are having to inform primarily the Indian community, and it is jointly by ORSI and Informs, and to inform the Indian community about the practice which is going on. And this is a work which has been done in JSW. But before we go to this, I would like to hand over to Rajesh, and he is going to talk a little bit about Informs, and then I'm going to talk about a little bit of ORSI and practice price, and then we're going to hand it over to Janki Padi and Pradeep for the presentation. So now over to Rajesh.
Oh, all right. Thank you. Thank you, Gautam. So, hi, everyone. I'll just take 1 minute of your time here. So just to give a little bit of a background, Informs is the Institute for Operations Research and Management Science. And the Informs practice section is a special interest community within Informs that supports the practitioners in this area. So to that end, we hold a number of activities or events throughout the year. So we have the three major annual competitions, the Franz Edelman, Daniel Wagner. So we are very honored that Informs as a whole has entrusted us with running these competitions. These are Informs level competitions, all very prestigious. We also have monthly or periodic events. One is the webinar series. This is an example of that. We have quite a few webinars which are focused from American companies. We have a few from India, all the work that Gautam has been doing. We also have a virtual networking happy hour, which takes place every Friday, last Friday of every month. And this is where you get put into some virtual rooms for about 10 minutes with about 3 or 4 other people. You talk about certain issues, get to know them, and then you get put in a different virtual room to get to know different people. So that has been very well received because this is something that our community has been asking, this networking opportunity. With all said and done, again, you can go to the practice section website, and if you look under, there's a tab for events. If you click there, you will always see past webinars, which are always recorded, or upcoming events. And if you go to About Us on that homepage, you can find out about what does practice section do and how you can join the practice section. So I'll hand it over to Gautam.
Yeah. Thanks, Rajesh. So we have started this OR practice core team, ORSI practice core team, which is a mixture of academicians and the practitioners, primarily with a practice focus. And we have several people in our team. We now at this point about 22 people are in our team with I am ex-IMA, retired faculty from IMA, and I have worked in Tata Steel long time back. Then you have Sanjay Kumar Prasad, Dr. Siddharth Sengupta, ex-TCS and IIT Bombay, Sankarsan Basu, ex-ICICI and I am Bangalore faculty, Bodha Ramkumar from Swiggy, Sundaraballi Narayanaswamy, IIMA faculty currently, Sumita Sharma. And we have started this practice prize competition, which is an event which we actually do at IIMA every year. And this last year we started that with jointly with IIMA, or before that we have done with only with ORSI. So IIMA, ORSI, Center of Data Science and Analytics of IIMA and ORSI, we do this national practice prize competition. This year we received 19 entries, out of which 6 will be selection. Selection process is going on, so I cannot tell anything more about that. But the first prize selection process will happen on 11th January 2026 at IIM Ahmedabad. We welcome for the future competition 26-27. An advertisement will be there from February 2027. And our idea is to create a national team of volunteers who will encourage the promotion of real world analytics. What I have found out that there are people who are doing extremely good work in terms of our practice, but they are possibly not getting the recognition which they deserve. And this is an idea to have the practice prize and having the practice seminar to bring their work to the forefront. With this, I will hand over to Sundaraballi to speak about little bit of ORSI Ahmedabad chapter. She is the president of the ORSI Ahmedabad chapter. Sundaraballi, are you there?
Yeah. Good evening, everyone. Thanks, Gautam. This ORSI research practice competition, it is conducted by Informs along with IIM Ahmedabad ORSI Ahmedabad chapter. And this time we have received quite some interesting and good work. We have all a couple of evaluation teams have worked on that, and then we are trying to, the main objective of this entire exercise is to kind of link, understand war applications in real life applications in the industry, and kind of giving a space, a visibility, and to show from the Indian context what we have been doing. And this time experience has been really good so far. And we have got some interesting participants, and we are going through the evaluating the submissions this time. So we want this exercise to continue and grow in future also. Our earnest attempt has been towards this. And thank you so much.
Thank you, Sundaravalli. I now hand over to Janki Padi, who has worked on this project, and Pradeep Agarwal. Janki is working in the JSW for quite some time, and she is an engineer, I think electrical engineer, and then she has worked also in Blue Star, in L&T, and one or two other industries. And she is actually the main author on this work. And along with this, we also have Pradeep Agarwal, who is also the leading this as a DGM in product and technology, and at JSW is an ME in material engineering and BTech in metallurgy from Nagpur, and he is working in the digitization project at JSW. With this background, I'm now going to hand it over to Janki, and she is going to take the page and going to speak for about 35 minutes, which will be and after 35 minutes, we'll leave it for question and answer session. So over to you, Janki.
Hey, while Janki is putting up the web slides, I just want to remind folks, we will look, you're all mute, and if you need to, we suggest that you click the Q&A button if you have any questions during the presentations, and at the end of the presentations, we'll go through the Q&A. And answer those questions. So again, click on the Q&A button to pose your questions anytime during the presentations. Go ahead, Janki.
Yeah, I forgot to tell that. Yeah, please put it in Q&A. Give a question. Yeah.
So thank you, Professor Gautam.
Mhm.
Thank you, Professor Sundravalli, and thank you, Mr. Rajesh Tyagi, for giving us the opportunity. Janki, you can start. Okay, I'll start. Make it in
Okay.
full screen.
I'll
So,
finish it in 35 minutes. Yeah.
yes, sir. Yes, sir. So this project is about the data-driven optimization of ferroalloy uses. Ferroalloy are the additives that we add in the crude steel. Crude steel is a kind of pure iron where we add certain chemistry elements to get the required chemistry. So this project will be talking about the how we introduce the digital solution to make it more process efficient. The flow is introducing the JSW steel and the business challenge solution approach, then the model implementation. We also develop a dashboard, and after that there is a summary. Next slide. About JSW Steel, is a fast growing steel producer, and there is a present capacity of 35.7 million tons per annum. So this is the largest steel capacity in India by an integrated steel maker. We also have plant in USA where the capacity is 1.5 million tons. We have a plan to grow to 43.4 million ton by September 27, and by 51 million ton on financial year 31. Present market cap is $29.4 billion. So it's a large organization, and whatever small change we do in the process, that like even if we save 1 rupees, if get multiplied by 10 million, which is 1 crore, so that is a saving of 1 crore rupees on a yearly frame. So we talk about a very small improvement, making it digitized to get the standard benefit, and the benefits are huge because of the volumes. Next. Steel, now we have 6 integrated steel locations across India and 1 in USA, which is in Ohio, where we use raw material to produce steel product. And then we have downstream locations, which are more than 10 across India, to produce the downstream product like cold rolled steel, coated steels, electrical steel, etc. So we are widespread across India, and globally we have the mines and availability, our presence is there. Next. Steel is a basic commodity where we make multiple type of finished product. Our finished product is mostly the raw material for other industries such as appliance to make the appliance, automotive to make the car bodies. So we produce the base steel and they in turn use it to make the final application. And we are supplying steel to almost all the known application of steel, such as in infrastructure construction, bridges, roads, consumer durables, pipe tubes. Different type of steel products are also there in flat product and long product. Flat products like hot rolled plates and coils, cold rolled sheets, etc. Long product typically includes wire rod, TMT. So we are manufacturing all kind of products which are used in turn by the secondary industry to make the end components. Next. As I said, if making small change give a huge benefit, and digitization has helped us a lot. Now we are the lowest conversion cost steel industry across the globe. World Steel Dynamics has recognized this. This has been possible by continuous digital intervention in many of our processes involving manufacturing, supply chain, mining, sales, marketing, human resource, and finance. We have a vision to go in we have a vision to go industry 4.0, where whatever it is a labor intensive industry, but our objective is to make it more smooth and sustainable and have a visualization for a faster and smooth decision making. So we have made small cells for improving or introducing digitization in every activity we are doing. The major focus is on automation, integration, and intelligence, end to end functional transformation, and being future ready for the digital workforce. Next. Coming to the project focus, now we will talk on the business challenge. Before talking to business challenge, I will introduce how the steel we are manufacturing. So first, we are having raw materials. For us, the raw material is iron ore. To produce steel from iron ore, we are using coal and coke. They are the reducing agent. Iron ore is something like iron oxide, and we need to remove this oxide from this iron by melting. So this fuel is acting as a two roles. One is to give us the heat, and second is to reduce that iron ore to iron. Then fluxes are added to get the desired composition and activate this process. So these raw materials, first they get beneficiation to upgrade the quality, because nowadays in India we are not able to find a very high grade iron ore. So we have to use a low grade iron ore by putting a process where we upgrade the iron value and get the desired concentrate or agglomerates. Agglomerates are like pellets and sinters. These agglomerates then we charge into iron making units. There are two type of iron making unit, Corex and blast furnace. Blast furnace being our largest unit, it get the feed of pellet, sinter and coke with the fluxes. Then it melt everything, it separate out the oxide in the slag and metal is being made. We call it as a hot metal. Now this hot metal goes to the steel making unit, which are hot metal pre-treatment to remove some of the impurities. Then we charge it in converter. Here the hot metal is converted into a kind of crude steel, which is a pure steel having very low carbon and very low other impurities. To get the, or similarly in electric arc furnace we do the same thing like we do in the converter. Then we use this steel to add additives which give us the desired chemical composition. These additives are being added in terms of ferroalloy, for which our project will be on focus. Then we have a two routes, one is for flat product, one is for long product. Accordingly we cast either the slab or billet, and these slab and billet go to the downstream process like hot rolling, cold rolling to give us the finished product for us. So this is the simplified view of our manufacturing process. Next. If we further simplify this, so there is the iron making unit which produces the hot metal. On the right side you can see the typical composition from the blast furnace. The carbon is high 4.5%, silicon is high 0.8%. Then there are impurities like sulfur and phosphorus, and manganese is also there 0.06, 0.1% based on the raw material we charge. This blast furnace, then we make pure steel in the converter which have the very low carbon, because we burn this carbon by oxidizing the process. We put lot of oxygen in flow and then we burn this silicon in silica by again with the same oxygen. We reduce the sulfur and phosphorus by adding the additives and fluxes, and manganese is also reduced. After that, in the caster, which is a final steel making process, in between converter and caster we add ferroalloy to get the desired composition. Next slide. So based on the final product requirement, let's say we have more than 2000 internal grade which has a specific chemistry requirement. So for each specific chemistry requirement, there is a different combination of ferroalloy that we charge. But example of 4 type of product, one is cold rolling, where we need low carbon, low manganese, so less amount and low strength. Ultimately, the purpose is to get either the desired strength or a desired functional property in the finished product to get the, then accordingly the chemistry is decided. It is the example of chemistry and strength are linked. If we boost the chemistry on higher side, typically the strength goes up and we need more ferroalloy. So depending on the grade requirement, the ferroalloys are being added. Next. Now why we need a model? For each ferroalloy there are multiple options. For example, we can get the same manganese of 0.1% if we charge low carbon ferromanganese or medium carbon ferromanganese, metallic manganese, high carbon ferromanganese or silicomanganese. So the operator has the option whether he want a high cost material or a low cost material. For the same 0.1%, if he use a high carbon ferromanganese, the cost is only 131 rupees for each 0.1% chemistry addition. While if we use metallic manganese, the cost is 269 rupees. So the selection of right ferroalloy based on the given operational condition is the must requirement for overall optimization of the ferroalloy cost. So this model talks about how we optimize this. This was, since steel making is an ancient process, people are doing this. So mostly it was driven on an experience level. Now we are having a data driven process to have it automatically selection for the method of adding ferroalloy and sequence. So this is about the basic overview. Next. Earlier also there was some optimization, but what we have done now is we have integrated the optimization across the value chain. For example, if we have lot of variation in the raw materials which are iron ore, coal, coke, etc., this variation get transferred to the hot metal. So it lead to the large variation of hot metal chemistry. So one of the challenges is how to handle a different incoming composition. Second challenge was how to handle the process abnormalities or process conditions to align with the ferroalloy requirement. All the time we cannot charge the low cost ferroalloy because the process is not favorable to us. So what are the variations we are getting? What are the dynamic constraints? The bath condition is difficult to predict. For example, the oxygen level and temperature. There can be delay in the test results. We do not know dynamically what is the exact composition is there in the metal or slag. So there is a need of identification of chemical composition of each element so that the operator do not wait for the test result, he directly do something. And then there is a productivity focus. We may not have sufficient time to take decision if we wait for the right samples. There can be communication gaps because multiple operators are involved. There is a dynamic conditions, high productivity mill is there. There can be some communication gaps, and if right ferroalloy not available, then he will charge whatever available, the high cost one. Similar ferroalloy availability, then there is a recovery. Each ferroalloy has certain recovery because either it will go in the metal as a pure form or it will get oxidized and go in the slag. So there is a recovery factor, how much is going in the metal, that is important to us. So for critical ferroalloy, we want that it should be avoided to go in the slag. We should not put lot of oxygen or the process conditions, so we lose the recovery. So these are the dynamic constraints while we manufacture the steel. Next, coming to the solution approach. Next, as I was saying that there is a process variability for bath oxygen, how much oxygen we are left before adding the ferroalloys. If more oxygen is left, then ferroalloy recovery will be affected. Ladle time, how much time we are putting for dissolving those ferroalloy and making it homogenized across the bath. What is the temperature? Temperature plays a crucial role in deciding the suitability for the next station, whether we are re-arcing for the temperature. If the re-arcing, then the chemistry get disturbed. Similarly, what will be the sequence of addition, whether we are adding high cost ferroalloy first, low cost later, or dissolving, all these things. And then loss, how much is getting in the loss in the slag, what is the impurities in the final steel. So this is from the recovery front. For the cost front also, there are some consumables, they are considered part of ferroalloy or total cost, which are like aluminum consumption to annihilate all the excess oxygen, lime consumption to prepare a required slag quality or chemistry to get better inclusion cleanliness, steel clean steel, synthetic slag if we are using for getting the clean steel again. Then difficulties in operation are like data accuracy, manual adjustments are there, all the things may not be recorded, so the people do manual adjustment to match the stock. There can be chemistry deviations because we are not able to hit the right chemistry on the first go, so we wait, reiterate and do manual additions till we get the desired chemistry. So all these process variabilities are there. The first objective was to convert manual ferroalloy practice to the logic and rules. So this is how we start developing the solution. Next. So 2014 we combined the logic and operator understanding on a basic rules that was converted into Excel. Then in 2016 some of the missing data was there, that load cells not there, we are not able to know the exact usage of ferroalloy or the ladle weight. Then we contacted a third party, a prestigious third party to develop the model. They did develop the model, and similarly another third party we have to contact in 2020 to okay. So but the problem was there, these third parties were coming and discussing with the top management, the managers. These managers were agreeing with them because it is logically right, but the operator were not agreeing, their experience was not matching. So to understand them well, both these third party could not deliver the solution that the operator was accepting. So finally we decided to go by our own. We discussed with the operator and then we ask them to give us all the input. Then we develop a basic ferroalloy model and that we deploy by ourselves in a digital dashboard form, we monitor also. Next. So as I already said, there was an old practice where everything was manual and there was errors, delays and then chemistry deviation, which is loss of quality. Then this new practice could deliver us optimized selection of ferroalloy, what is the best possible weight in each different process factor, real-time data for heat chemistry process parameter, and then integration with the existing database for live heat process, cost reduction, and avoid the resampling re-addition to desired compositions. Next. Now I will request Janki to continue.
Good evening, everyone. Thank you, Pradeep sir, for explaining the problem statement. So now I'll start with the technical part. So how we develop this model. So to address all these problems, we developed a linear optimization solution. The solver calculates the optimal ferroalloy weights. Just
Next slide.
my presentation is not working. Okay. Yeah. I hope it is visible now. So,
Yes.
Can
so the key
everybody see
benefits.
this? Just a minute. Can everybody see this presentation? Ferro optimization is still making.
Yeah, we see that. I see that.
Okay, that's fine. Yeah, Janaki, continue.
Yeah, thank you. So the key benefits for this optimization solver that we were using were faster achievement of target chemistry, lower ferroalloy consumption, reduced iterations in steel making, and consistent chemistry control across grades. So let's go to the technical approach now. So as I mentioned, this optimization engine works on linear optimization programming framework. So this solver minimizes two things. First of all, the overall ferroalloy cost, and secondly, the deviation in carbon and silicon chemistries. The model takes inputs such as initial steel chemistry from level 2 systems of our infrastructure, then recovery rates of each alloys, target chemistry, and then availability of ferroalloy cost according to the real-time basis. So based on these inputs, it computes the exact quantity of each ferroalloy. In any ferroalloy is unavailable, the solver automatically adjusts the mix and choosing the next best alternative within the cost and the chemistry constraints. So unlike machine learning, which requires large historical data sets, linear optimization solution provides a deterministic, globally optimal solution, making it reliable and scalable across different plants. So the architecture now we'll talk about. So this architecture that you see on screen is of Salem plant. So there are multiple levels, as you see, like the OT network, the DMZ zone, and the IT zone. So all the data that is collected from the heat-wise data is coming from the OT network, and the DMZ zone is where our solution is implemented. And then the IT form, we take our data, all the data for model input and output, and it is visualized on the dashboard, which I'll be talking next. So in this architecture, if you see, there are three basic layers. One is input layer, which captures real-time heat-wise data that consists of ladle furnace data, chemistry data, initial chemistry, which is required for the basic input, and some of the manual entries are also taken into the consideration from the model, which operator gives. So then second is the optimization layer, where our solution works, takes all these inputs and gives them throughout the particular output. And then is the output layer, which is displayed using Flask Flash UI and suggests the alloy additions according to the weights and the available ferroalloys. So the system is also connected with Oracle database for process data and costing inputs, while Azure Synapse handles ETL pipelines to clean the standardized information. Now this is the model screen that is deployed on the Salem plant. So as you see there, this is the input tab. So there are particular input variables that operator needs to add. If they add the current ongoing heat, then all the they have to press the get data button. Then all the input variables and the heat wise data are fetched from the data sources, and it is displayed over here. Then they have to make changes accordingly if they need to add a certain variable, like we have here as a silent mn. So there they are back calculating and putting the value. So then they have to refresh the model and get the output data. Also that you can see a screen where you can select or deselect a particular ferroalloy. If suppose in that ongoing plant for that particular heat, the grade that we are going to produce, if any particular ferroalloy is not available, the operator can uncheck it and the optimization model will run accordingly. This is the output screen that you are seeing on the dashboard on the screen. So you can see first column, which recommends the weights according to the chemistry grade that we need to achieve. You can see on your right hand side expected versus actual chemistry. So minimum and maximum specifications are given. What was the initial chemistry of that particular heat we have retrieved from the database, and then model calculates the values according to the weights that it has recommended, which is basically in kgs, and we can check that it usually targets at the lower end of the specification, meaning it targets at the minimum side. So then you can check what is your aim, and accordingly the additions are done by the operators. So next part we'll go, which is of dashboard implementation. So for dashboard, after all the model process was done, now there was a need for analytics also, to monitor the previous data that we are producing each heat wise and see where we can do more improvements. So on this dashboard, we have developed this dashboard on Power BI and using Azure services. So we collect all the data from the OT network, bring it to the IT zone through SHIR, which is self-integration runtime. So from there, we parse the data into Azure cloud. We have a storage over there, and then all the ETL pipelines are created, and we take this data to the dashboard. So okay, so let's go to the architecture. So this is a high-level architecture of Ferro dashboard. So as you see, we collect data from different data sources, which is Excel, Oracle, SQL for live data, and SAP for inventory and cost-related records. So then it is integrated with the Azure infrastructure. Like Azure Synapse Analytics performs the ETL process, extract, transform, and load. Cleaned and standardized data is stored in Azure SQL database, and then from there Power BI, we take the inputs to the Power BI dashboard where the reports have been generated. So this is the current dashboard. I am showing you this data for Dolby plant for SMS2 location. So as you can see, we have one single platform for all the plants. From these plants, you can select even multiple plants as well, or you can select data for only a single plant. And then you have to select the shop, which means steel melting shop. For Dolby, there are two, like SMS1 and SMS2. So you can view it overall as well, or else plant-wise. So there are some other filters also, which for analytical purpose, like you can go till the heat from shift grade till the heat level. And then there are multiple KPIs that you see on the dashboard right now. So basically, overall, this dashboard gives heat-wise steel weight and alloy consumption, actual and standard comparison, and standard and model suggested comparison. So what are the actual consumptions happened for that particular heat or grade? The standard, which is a norms that is set, like a basic number, you can say, like this is a standardized input that you should go for add for a particular ferroalloy for a particular grade that we are producing, and then the model suggested value, what the model was suggested, and then we are making the comparison. So now if you see here, this is gap actual versus standard and gap actual versus model suggestion. So this gap is in positive, means there was a 64 rupees saving potential, which we missed in Ferrola actual cost to what the model bit suggested. But there is like some constraints that we cannot bring it to zero for certain grades, and due to some constraints. So this was actually the previous 2024 data, which I'm showing you right now. Now, if you see, there are positive inputs that has been refined, and we are having a basic cost saving impact also from which is also visualized on the dashboard. So there are other KPIs also apart from the cost that is on the dashboard, which is consumption, where we show all the heat or grade wise consumption for all the materials within different plants as well. The rates are visualized, and then the chemistry part is also a major KPI in this dashboard, where you can check what was your expected chemistry and how much compliance we are doing for each heat. And there is also an inventory level KPI page where we are working right now, where we'll be incorporating all the data from inventory level, like what is available, how much planning we need to do, what the materials we need to order. All these KPIs will be managed on an inventory dashboard, inventory page. So how the monitoring part goes now, let's explain. The monitoring method in data-driven and AI-enabled environment, each heat is analyzed for cost deviations. Then in, sorry, just a minute. Yeah. So as I was explaining, each heat is monitored according to the deviations, and this deviation is then calculated in rupees per ton, whatever the consumption has happened. And then we go to the drop down to the root cause analysis, allows operators to tag reasons such as recovery variations, temperature loss, or alloy unavailability. The system learns from historical patterns, building a knowledge base of preventive actions. So this allows future heats to benefit from past lessons, making process self-improving over time. So there are, like if I talk about the benefits plus from this monitoring, there are tangible solutions which we have like cost reduction of around 30 to 40 rupees per ton of cost saving we are doing across all the locations, which earlier this KPI was around 150 rupees per ton. Gap was seen between the actual and standard ferroalloy cost between the gaps. Then there are operational benefits as well, reduction in alloy consumption, fewer iterations, and faster production cycles. Quality is improved according in steel chemistry, reducing off-heat grades.
Janki, you are on last slide, right? It's not moving
Yeah.
slide. Just come to the next last slide.
Okay.
Yeah. Okay. Yeah.
No,
Okay. After this.
Yeah.
Okay. You can explain this.
Yeah. So yeah, in this slide, you can see the tangible benefits also. From this is the data from 2024 that we have calculated. So as you can see, from Dolby plant, we have around 118 crore of benefits, and till date, till October 2024, and the other plants also, it is visualized over here. So these were the intangible benefits I was talking about, the quality and the standardization process that goes on in the JSW. So my last slide. So let me talk about the sorry. Yeah, let me talk about the cross-industry relevance from this. So this solution that we implemented, it's not only restricted to steel plant that we were talking about. This is one problem we tackled through this solution. So like if basically overall, if you see, it is particularly cost reduction and consumption reduction optimization solution. So these solutions can also be implemented in different verticals like supply chain, energy, retail, and healthcare. There are other use cases also that we can go through, but these are the major use cases where the optimization could work and giving out the specific benefits. So now I'll hand over to Pradeep sir to give us concluding statements on the overview of the project.
Okay. So I think this all part is done. So we are open for questions.
Okay.
We
I
are
think
done.
I
Thank you.
leave it to open to the attendees to come out with their question live other than writing their questions. So this time we did not allow the writing questions. Whatever your question is there, you can ask live, and Pradeep and Janki is going to answer that live.
You can unshare screen, Janki.
Yeah.
Yeah. Rajesh,
I don't think.
Okay,
Gautam,
okay.
I don't
Let
think
the screen be there. If question will be specific to screens, we will give the slide number.
Yeah.
Yeah.
Gautam, I don't think people can ask questions directly. I don't think.
Oh,
they
people
have-
can ask questions. So they have written.
No,
Okay,
no,
they have
no.
written.
I think they need to enter the Q&A in the Q&A. They're not allowed to ask questions. I don't think so. It's not been
Okay,
said.
okay.
So Pradeep,
Sorry,
I
I
know you
think
answered. Pradeep, you answered a couple of the questions already. Can you just repeat those questions and speak them out, because not everybody will have access to those.
Okay, so
So-
there were just a basic question, what were the equations used? So we have used linear equations, most of the line items, but some of the line items has dependency on the process conditions. There we are using some artificial intelligence models using Python, and those equations we have done to process optimize, because they are the resultant of the process conditions like aluminum consumption, slag consumption, calcium consumption. So those things we have done a non-linear kind of model, but most of the line items like standard ferro alloy, we have a linear model, and we are using it for every heat we are producing it, because it has, and then the operator should know for the given heat or process condition what he should add. So it has to run live to the operator, and then later on analytics is used to analyze whether we hit the target cost or not, target chemistry or not. If not, then why. So those are done after this, but live it is there. And then logistic is handled mostly railroad. I don't understand that question.
Pradeep, if you can read the question also, again, not everybody has access to
yes,
the
I
question.
think there is one question for Sarthak and one is for Ashish. Paul. So how is
question was-
logistics handled at JSW Steel in in-house 3PL? How much percentage is done in rail? Then I am doing MBA in supply chain job opportunity. I think job opportunity another. I don't know whether this is the right forum for doing this.
Yes.
But how
So the
logistics
logistic
handled?
is
Let's speak over that.
in-house
Yeah.
logistic is all through the rails, mostly through the rails, because and there is a rail network inside to produce, to shift hot metal to steel making. Then from steel making, there are direct conveyor, direct charge systems. So we have in-house logistic, which is uh, avoiding the road transport as far as possible, and then outside logistic mostly through the rails, and then export is through the ports, and some of the, yes, from the road, which are nearby stations, we are supplying the material from the roads.
Okay. The second question is that based on experience, one of the challenge is the amount of grades one has to produce in a plant, and having common model for all grades makes it difficult. How do you tackle immense variability across different grades and high prediction accuracy? I think this is an interesting question.
Yes, this is the question we actually answered. The other third party is what is not able to address this variability. So we have more than 2000 internal grades. Each grade has a specific requirement of chemistry as well as steel quality in terms of cleanliness. So first model is to target the right chemistry. Second is, in the process condition there is an alternate quality monitor. So we have developed a digital quality gate in each process to address that variability and cleanliness issue. So right now we are talking ferroalloy model, but this model is actually supported by a quality gate model, which is what should be my process condition to get the desired quality after each stage.
Okay.
How this model reduce the iteration of mixing to get the right chemistry. Yeah, it done by the historical data was used as a reference, and then there is no iteration now. We directly charge and we know how much recovery is going to come, and in one shot we achieve the target chemistry.
Like for each ferroalloy, we have a particular product specification as well. So each ferroalloy, how much chemistry specification we are going to achieve, that is already predefined. So it is not like product specific, it is like composition specific. So any yeah, so there can be a list of ferroalloys. It can change accordingly to the market that we are procuring, but the composition remains the same. So whatever percentage of carbon or manganese is going, that particular product is going to have, according to that we calculate the model chemistry, and then we try to achieve at the minimum side of this chemistry, and we don't undershoot or overshoot accordingly, and then we only target at this minimum range side.
So there is a demand which is there in the market. And according to the demands, also the specific demand for the steel has its composition. And you have the odd metal or the liquid steel composition. So how do you match that the demand, this demand to that steel? So, and
See,
also
that,
minimizing
first of all,
the cost.
yeah, that demand is basically in terms of how much order we get in every internal grade or a target chemistry. So
Hmm.
there is a planning model available. We call it advanced planning system, which actually match and decide that how many heats, because one heat is one lot to us. If it is 180 tons, means 180 ton has to be with same chemistry. So first of all, there is a clubbing that multiple customers giving small quantity or a one customer giving large quantity. We produce a required number of heat for each grade. Then from that one heat, now how do we produce that one heat in a lowest possible cost? Then this model act as a main support.
So this is 0-1 integer programming is there, or is like a just material balance for each type of compositions like carbon balance, silicon balance, input and output level. I think what is
It's
that?
more on the
How does the
balance.
optimization
Yeah.
work? Which is that objective function constraint like wise? What does the optimizer
So
work?
optimizer is selecting the right ferroalloy. Each ferroalloy, the low cost ferroalloy typically has high impurities. Now steel has a constraint that we cannot increase the impurities after certain bounds.
Right.
That is first thing. So selection of low cost ferroalloy and maintaining the process conditions so that that level of impurities are tolerable in the given heat. That is first thing. Second thing is this model also act on the root cause and implementation for the forthcoming heat. If there is a deviation happen for a given heat, then somebody from a senior level should know why this happened, how we can avoid in the future to save on the cost.
So
And
I have
what
a
was
question.
sorry, what was then differently that
Yeah.
actually make an admin or you can say the operator to accept this model rather than which was built by a third party or anybody
Yes.
else? I
So
mean,
that
what
is the
was
main thing. The third
differently
parties,
right now?
yeah, third parties was having a broader baseline. For example, they were having assuming the process. Assumption 1, 2, 3. Only three assumptions are taken, then the model was developed. But in the dynamic process, there are not three, there are more than 300 constraints that operator can feel. So until unless we address all those constraints that are being felt by the operator, then operator will not readily accept. He always have the excuses. So with that excuse, if he will not use the model, then the relevance of model goes down. So we first have to consider all the operator experience. We have to make them in our trust that okay, this kind of model is going to help you in this way. Then we did all the trial testing and the working with the operator to develop the model. It's only engagement with the operator level, not to the management level only.
And
So
is the operator who is running this model live at a
Yes,
heat level or is it done
yes.
on the
It's live
No,
running
I
and
think it's
operator
live.
is working as per the model. Now we actually remove the operator control also. We are doing auto charging. So as the model will suggest how much to be add, there is no operator intervention. The system will allow that much amount of charging of that ferroalloy in the given heat. So the operator itself has been removed from the decision making.
So I have a question, and
Yeah,
before I
Rajesh.
ask,
Yeah.
I made everybody sort of unmute so they can ask questions now. But my question is this: so you talked a little bit about your steel plant locations and so on. Can you talk a little bit about your organizational setup? I mean, where is your analytics team located? Is it in one
Yeah.
location?
It's
And
interesting.
how is it divided by different,
Okay, so like
expertise
Janki is
areas?
representing the data analytics team. She is working on a central base on a Mumbai. So we have an office in Mumbai that control all the locations. So she take care of data analytics and there is a complete IT team with her. Then there is a local plant IT team or digital team is available where they support the user. Like I am a user, but I am also a central user. I am not a local user. My role is the central quality management. I am looking 17 locations like in India and USA together. All the quality and technology roadmap we are building, the challenges, best practice sharing, horizontal deployment, all these things. So we have a central digital team which is Mumbai, local digital team at each plant. We have a central quality team. Right now we are sitting in Vijayanagar because this is our largest plant, but we have a local quality team at each location. Similarly, we have the local operational teams at each locations. So they are the user. They we identify the challenge, opportunities for reducing cost, improving efficiency, customer quality. We convert it into a kind of a logic. Then we give it to our local digital team or a central digital team. In case we directly give to the central digital team, this local digital team define this problem in a way it can be analyzable or understood by a the local, the central IT team or digital team. Then they make the programming to us. They give us the interface where we can give the input output, and then there's a training testing of the required models. So we are very much into developing many models, very small models for every process. Whatever we are doing manually, now we are converting into a digital way.
So how do you select your problem? Which problems do you take for? Because you might be getting so many requests.
Yes. So the first selection method is zero cost. So whichever problem do not require any investment and only give the benefit. So they are directly taken. Second is how much efforts we need to put, because there is a limited manpower we have in a local digital and central digital. So they have their own criteria. The criteria is how much annual target potential of cost. For example, if anything is below less than 10 crore, 20 crore, they will not even see it. So their criteria is I will work only on a high margin, high gap products. Third is how many sensors, how much cost is involved, whether we need any additional third party to engage to work on this. So there is a ROI concept. So anything which has a ROI less than 3 months typically go ahead with the management approval. More than 3 months is very difficult until unless there is a push.
Anybody else has questions?
Any other questions? Yes.
I I have three questions.
Yeah,
Can I?
please. Yes, please
So,
meet Surya.
yeah,
Yeah.
hi. First of all, yeah, very good presentation. My first question is, can you highlight how much was the benefit in terms of implementing this? Because we never saw what savings you did.
So it is
Maybe in terms of percentage, if you cannot give an actual figure.
no, I will tell you. It is actually more than 100 crore rupees every year.
Oh,
Now this is cumulative every year. For example, only in Dolby location where we have a 10 million ton plant,
yeah.
complete deployment of this model has been done, and the first year saving is itself 113 crores or something. Now the second year, that whatever we have saved, actually there was a gap of 15 rupees, 150 rupees, that we reduced to 20 rupees. Now that 20 rupees will become the now the next year base, and whatever we reduce 20 to 10 rupees, that 10 rupees into 10 million ton, that will be the benefit for the next year. So
Yeah.
likewise we are calculating for each plant, and
Okay.
like we are 27 million tons, so we are targeting around 270 crores a year minimum saving. This
It's
is still in
very nice.
deployment on a complete horizontal way.
Yeah, got it. I might have missed the initial slides. I'm sorry for that. So
No
sorry
problem.
if I'm repeating. Yeah, my second question is that you brought in two third-party model developers or solution providers, and then you went it in-house. So what I'm understanding is obviously they were experts in their field, right? And then, but there are some components that miss. So
Right.
all of us here will be some sort of OR specialist, right? But then there are human factors, there are organizational factors which sometimes experts miss. So, what would be your suggestions to look out for when we are going from mathematical to practical solution development? And what should we look out for? What should we avoid? I mean, something like that.
So the first thing that what I feel, because I work with those third parties also, there is a data accuracy concern. For any industrial process, whatever data we receive, that data is not in the right analyzable way, and then there are human factor to define the data. So there was consolidations in the data. So like somebody has a target of day target to maintain certain ferro alloy cost, he will do consolidation. There is a stock mismatch, he will do consolidation. Those consolidations were giving a wrong input to the next team to digitally analyze. When they digitally analyze and come out with a solution, that solution was absolutely with the errors because the input data was not rightly filtered. That is the first challenge. They could not give a solution that is acceptable to most of the heat. It was acceptable to some of the heats. That is one thing. Second thing is the operator which are doing this, he should be taken into confidence or discussed. At least he should be thinking that he is being valued. So when that happens, then only he accept and go for the next level of trial and validation. So these two things, if we would have been done with those third parties, the data accuracy and operator in confidence, then might be we could have made the model in the first trial itself.
Okay.
मेरे को देखे जा.
Okay. Any other question?
Thanks for that, was very insightful and very nice presentation.
Thank you.
If there's no other questions, then we are going to. If there is one, is because of reduction in cycles you achieve and the chemistry, it helps to improve yield on production in plant beyond cost reduction in Fe alloy. The Ashish call. Did been answered?
Yes, I guess this was answered by Pradeep
Okay.
sir. He actually
Okay.
mentioned regarding the
Pradeep sir has
yield part
answered
also.
that. Okay. So if we have any no other questions, then we can call it. Sundaravali, you have any questions, suggestions?
No, good presentation.
Okay, good.
Thank you.
Thank you. So Rajesh, so thank you all for coming here, and we are really thrilled to see that we had 47 participants at one point of time today, including the panelists. So which we can see on the average, the number of attendees are going up. Really, started with over 30 plus. Now we are giving every day, every time we are doing. We continue to do this in the future, and by possibly 1 month we will have our finalists ready for who will be coming from IIM Ahmedabad in the first week of January, the second week of January at IIMA to give the presentations. So any one of you would like to give a presentations of this type, you can contact me or Rajesh, and we'll be happy to organize a talk for you. And thank you again. Thank you, Janki. Thank you, Pradeep, for doing an excellent presentation.
Thank you all.
Rajesh, Sundaravali, thank you all. And thank you all the people who have taken their time to come here for this presentation. Please continue coming for this.
Thank you.
Thank you very much, everyone. Bye-bye.
Bye.
Thank you. Thank you, everyone.
Thank you, sir.
Thank you all.